a block of mass 6 kilograms is placed on a rough horizontal table. The coefficient of friction between the table and the block is 0.4. A horizontal force P newtons is applied to the block, but the block does not move. Find the greatest possible value of P. Okay, so like all mechanics problems, you need to draw a force diagram. So we need to draw a block on a rough surface, which is 6 kilograms. We've got the weight acting downwards, so we'll draw the forces on here. We have the normal reaction. We've got a force being pulled. As it's going to be tending to move this way, then there will be a frictional force going that way. And as it's at limiting friction, F will be equal to mu r. Now it's a simple case of just resolving. So resolving vertically. You're going to have r minus 6g is equal to 0 because there's no movement that way. That means that r is equal to 6g newtons. And then resolving horizontally, we're going to have P minus F is equal to 0 because it's on the point of moving but isn't actually moving. And therefore we're going to have P, and for F we can use F is equal to mu r because we've got limiting friction. Mu is equal to 0.4. So we're going to have 0.4 times my normal reaction, which is 6g, is equal to 0, and therefore P will be equal to 0.4 times 6g, which is equal to 23.52 newtons, which to three significant figures is 23.5 newtons. So this has been a video to show you how to find the the minimum horizontal force needed, or the greatest possible value of P, so that the block does not move when we have friction. I hope you've understood, and I thank you very much for watching.